Hello everyone and welcome. This is the video for lesson 1-4 from the Algebra 2 book, Big Ideas, and it's transformations of linear and absolute value functions. All right, let's take a look at our learning targets for this lesson. They're pretty much the same, except for you're going to write functions that represent transformations of linear and absolute value functions, and I might throw in a quadratic just for fun. Once again, I have added this little table to help you figure out what to do with the function or what to do with the x, kind of depending on what transformation that you use. Just to remind you how it works, if you want to move something up, you want to add to the function. If you want to move it down, you're going to take away from the function. Moving left and right is different. You're using addition and subtraction, but you have to add or subtract from the x. So you can see right here it says x plus c, but it's not going to move it to the right. It actually moves it to the left. So adding to c is going to move left. Taking away from x is going to move it to the right. If you use multiplication, let's say you want to reflect over the x-axis, you're going to multiply the function by -1. If you want to reflect over the y-axis, you multiply x by -1. And if you decide to go ahead and multiply by something greater than 1 to the function, it's going to be known as a vertical stretch. It's going to pull it away from the axis. And if you want to multiply it by something between 0 and 1, it's going to be a vertical shrink, aka compression. So let's take a look at the examples. Now, these examples are going to be a little bit more difficult than you had in lesson 1-3 because it's kind of expanding on your learning. So you're really going to need to know what you're doing before you really master this lesson. But I'm going to try to help you as much as possible. So we have a function, and I'm going to go ahead and highlight it here. This function is equal to the absolute value of x plus 3. So it's not quite the parent function. It has been translated to the left, but that's what we have to start with. So they're giving you something to start with. So I'm going to immediately write down what I'm starting with. So I'm going to put f of x equals the absolute value of x plus 3. Then what I'm going to do is I'm going to do what it tells me to do. It says write a function g whose graph is a reflection in the x-axis. So I'm going to change this from f of x to g of x. And then I'm going to look over here, remind myself, what does a reflection do? So a reflection in the x-axis, okay, take a look at our little table here. So a reflection over the x-axis is this, and that tells us that we need to multiply the function by -1. So I'm going to do that. So my function is the absolute value of x plus 3. So I'm going to put a -1 here, and I'm going to multiply all of this by -1. Now that looks complicated, but all you're doing really is just multiplying this absolute value by -1. So the only real change that you're going to see is that there's a negative out in the front. That's it. Okay. Now there's a reason why I wrote it like that. You'll see in the second example. But what this is a reflection over x-axis. Okay. And what you have to do to create a reflection of the x-axis is you multiply the function. Okay. That function was the absolute value of x plus 3. You have to take all of that function and multiply it times -1. So if you look under here, this is new. We didn't do this yesterday. It says write a function, or write using function notation. So function notation is this right here, all of this column. And we're going to write down exactly what we just did. So if I want to show a reflection on the x-axis, I'm going to take that function itself, and I'm going to multiply that by -1. That's it. That's all you have to do. So the function notation is actually pretty easy compared to writing the actual equation. Now the second equation over here is exactly like the first one, except you have two parts. You see how you have absolute value of x plus 3, and then you have an additional part. You have that minus 1 at the end. Well, that's what we're starting with. So I'm going to go ahead and write this down first. There, okay? Then I'm going to apply what they're telling me to do. So it says write a function g, okay? So I'm going to do g of x. It says whose graph is a reflection in the x-axis. So I am going to do the exact same thing I did last time. So my function notation will be the same. I am multiplying f of x, the function, by -1. So that part's actually pretty quick. But what's going on here is I've got two parts in my original function. So when I multiply these two parts by -1, both parts will change signs. So I have the yellow part and I have the blue part. So my final answer is going to look like this. It's going to be negative absolute value of x plus 3, but then you have to distribute the -1, so that will be plus 1. If you don't do that, it's only going to reflect part of the graph, not the whole function. All right, let's take a look at the next row. We have f of x equals x minus 2. So I'm going to write down what they give me. And I'm going to highlight my original function. So it's a little different than what we just did because this is now going to be a vertical stretch. So to stretch, I'm going to have to multiply by whatever factor it is that they say to multiply by. So it says by a factor of 2. So if it says by a factor of 2, I'm going to basically just multiply the function by 2. That's it, okay? So let's do the actual math up here. I'm going to change colors. So this is now g of x. So for me to show that I'm multiplying by 2, I'm going to put 2 here. And then I'm going to put the function in parentheses. So all I have to do is multiply the absolute value by 2. And the only change you will see is there's a 2 in front of it. That's it. Remember, that has one part. It has the absolute value part. This one, on the other hand, has two parts. So when you multiply to the function, you're going to have to distribute. So it's asking us to do the exact same thing again. It says vertical stretch by a factor of 2. Same notation, multiplying by 2. I'm going to go up here. I'm going to write down what I started with. And then underneath, I'm going to start manipulating it. Okay. It wants me to stretch it by 2. That means I have to multiply the whole function by 2. Now remember, I have first part and I have the second part. So the yellow part needs to be multiplied by 2 and the blue part needs to be multiplied by 2. So my final answer is going to be 2 absolute value of x minus 2 plus 8. Let me make that 8 better. There you go. So if you just stick a 2 in the front, it's going to stretch, just not stretch all of the function. All right, so this next row is a little bit more challenging because we have 2 transformations instead of just 1. I'm going to approach it the same way. I'm going to write down exactly what I started with, and then I'm going to apply each transformation in order. So this one says let the graph of g be a vertical shrink by a factor of 0.25, and then we're going to follow that by a translation of 3 units up. So I'm going to write down the function they want me to start with. That is the parent function of a linear equation. And then I'm going to go ahead and do the vertical shrink by a factor of 0.25. So they want me to write it using g, I think. Yes, let the graph of g. So I'm going to take this right here. If it's a vertical shrink or stretch, you're multiplying the entire function by that amount. So I'm going to multiply that to x. All right, so this one's actually a little less complicated in some ways. So that's the first one. I'm going to change colors, and then I'm going to apply the translation of 3 units up. So if I want to go 3 units up, I can just simply add 3 at the end of that function. So if I can simplify that just a little bit, I'm going to write g of x equals 0.25x plus 3. So what's really important to notice, in this case, we are applying one and then applying another one. You're not doing them at the same time. So the order really does matter. So just take your time and follow the order. Let's go ahead and do the function notation. So we're going to do y is equal to, now remember you start with f of x. So to apply that shrink, I'm going to multiply by 0.25. And then I'm just going to simply add 3 to that. And that's that generic function notation. On to the next example. It says, let the graph of g be a translation 6 units down, followed by a reflection in the x-axis of the graph. F of x equals x squared plus 2. So we're going to start out with f of x equals x squared plus 2. And I'm going to go in order of each transformation. So the first one is a translation 6 units down. So if I want to create a new rule for g, I'm going to write all of this. And if I make it 6 units down, I'm just going to subtract. So translations you add or subtract to either the function or to x. In this case, I am subtracting from the function. And then what you want to do is you want to simplify what you just did. So you can subtract 2 and 6. So 2 minus 6 is minus 4. Then I'm going to shift colors and I'm going to do a reflection in the x-axis. So a reflection in the x-axis means you've got to multiply what you have times -1. So when I multiply this whole thing by -1, as we did before, and I simplify it, each part will change signs. So this is now going to be negative x squared plus 4. So that's my final equation function. Now, if they want me to do the function notation, this one's actually pretty easy. So I'm going to start out with y equals f of x. Left a little space here. So I've got f of x here. So the first thing I'm going to do is I'm going to add, nope, not add, sorry. We're going to take away 6. But then we're going to reflect it. So I'm going to put a -1 out in the front. And you can leave it just like that. All right, so you know we have to throw on a really good word problem here. So it says you design a computer game. That's pretty cool. Your revenue in dollars, that just means how much money you're making, for X downloads is given by a function f of x equals 2x, okay? So then your profit is going to be $50 less than 90% of the revenue. All right, so revenue is like how much money you take in, but then profit is going to be how much money you have after all of your expenses. So I'm going to write down this function that we are given. So 2 times x, okay? So we need to translate into math what is 50 less than 90% of the revenue. Well, if you want to find 90% of something, then that's going to wind up being 0.90 of what you started with. So to find 90%, you just take it and you multiply it times 0.90. So that's pretty quick. Then if I wanted to do $50 less than that, you're going to lose $50. So I'm going to subtract 50. So final answer, I don't think it wants us to change or anything like that. So I'm just going to leave it this, okay? So that's my modified function. And then it says, what's my profit for 100 downloads? So if I've got 100 downloads, that means I'm going to replace x with 200. And I wind up with 130. So if I have 100 downloads, that means I'm going to profit $130. Okay, sounds like a good deal. All right, just let me know if you have any questions, and good luck.